Alright, I accidentally clicked stop recording as opposed to unpause, so that's really annoying. But that's fine. So here, now this actually does involve chess knowledge, which I don't have. So find the number of ways two knights can be placed on a k by k chessboard so that they do not attack each other. So I guess number one is to actually look at where knights can move, which seems to be an L shape. That is an unfortunate representation of how knights can this one. So I guess here it's saying, you can go 1 and then 2, 3. 1, 2, 3. 1, 2, 3. So actually a knight can't move on a 2 by 2 chessboard. It could move on a 3 by 3 chessboard. But I wonder though how we kind of represent that the knight is like the different possibilities of where the knights can be. I think you would just have to hang on 1 second. I guess you basically just we take how big the chessboard would have to be. So let's see though, two knights between 1, 2, and n. The number of ways two knights can be placed on a. Oh, okay, so that they don't attack each other. So this goes up to 8. So basically, on given input 8, there are 1,848 squares inside. Where you can have two knights placed so that they do not attack each other. So actually, this would represent knight number 2. Now, what's interesting here is that I thought that knights can only move like that. So I'm a little bit confused as to why on a 2 by 2 chessboard there's 6 ways knights can be placed so that they don't attack each other. The only input line contains an integer n. A k by k so that they don't attack each other. Oh, okay. I see that now. Yeah. Right. So then on a 3 by 3. So what I'm thinking is that there's obviously some mathematical way of doing this because you're not exactly going to build a data structure that represents the chessboard and the number of moves each time, because you know if you can go up to 10,000, that's going to take way longer than a second. So there's some maths to this, but I don't really know. I don't really know what the maths exactly is. I think you would obviously have to take your you would take the total size of your chessboard. Yeah, I think we can actually work backwards, kind of. So you take the total size of your chessboard. And then for from 1 all the way up until the end of your chessboard, you plot out that if you place knight number 1, for example, here, where are its valid moves? And we take the number of squares, so aka size of the chessboard minus 1, 2, 3, or minus 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we just calculate it for each one. So for every position the knight can have, we take the size of the chessboard minus the number of valid moves the knight has. So I think the key thing here is that we're going to need a way of actually figuring out the number of valid moves the knight has. Which is simply that if we move let me just type some of this out. So let's get our number, n. And so our total chessboard size will be n times n. So we say that in position 1, if we know that this is... I'm just going to make this an int. And I'm going to make this a long, because I think signedness is actually going to have to come into play here. Because if we had the knight here, it can only move there. It can't move there because that's off the board. It can't move there because it's off the board, and it can't move there because it's off the board. So what's interesting here is I think you actually might need to use the previous answer as well. Possibly. So or it might be recursive. Possibly. Might be recursive. Because actually what I was suggesting there feels like it would be too slow. Because you're basically kind of brute forcing it. But I think there's some trickery you can do, yeah. Yeah, you can literally just take the previous answer in your... You can use the previous answer in your loop. And just kind of add that on to some kind of formula that we can employ to find the number of squares that are free for each move in the new row. And then that's a lot faster, I think. So would help if I can type. I think so. This is a 7x7 chessboard. So there's 1056 possibilities that on this chessboard, which I think makes sense. Oh, I need a I don't even think I have a calculator anymore. I don't have a calculator, at least not next to me. I might have one in the other room though, but because what I'm thinking is that if we just calculate like the extremes, which is basically if your knight is here, how many valid moves does it have? Well, it has 2 valid moves. 1, 2, 3. Yeah. 1, 2, 3. So, you know, there's 2 valid moves there. Then there's what, still 2 valid moves? Then there's 3 valid moves. Then there's 4 valid moves. Then there's still 4 for every square on that row. Then you have, you know, as you get to like here or wherever, you'll have 3 valid moves because you'll have 1, 2, 3, 4, 5. Yeah, basically, once you figure out like a base number, there's always going to be wait, no, that's not right either. This one may need coming back to because I've already been live, not live, I've been recording for kind of a while. I know it's doable, I just need to put the pieces together in my head. I'm a lot less initially stuck on this one than I was on that one. So, yeah, watch this space. Laters.